All right, welcome. Today, we're diving into something that's absolutely critical for Kubernetes security, how your applications actually talk to each other inside the cluster. We're going to take our network from a complete free-for-all and lock it down, turning it into a secure fortress using what are called network policies. So let me just ask you this straight up. Is your Kubernetes cluster a little too trusting? I ask because right out of the box, it operates on a model of maximum trust. Every single pod can freely talk to every other pod. And yeah, that's great for getting started quickly, but it's also a massive security hole just waiting to be exploited. Think about it like this. Traditional security, that was like a castle with a big moat around it. Super strong outer walls, but once you got inside, you pretty much had the one of the place. Well, Kubernetes by default is a lot more like a wide open city. There are no internal walls, no checkpoints. Anybody can get from any building to any other building, no questions asked. So this default setup is what we call a flat network. Every pod gets its own IP address, and every pod can ping every other pod. Its biggest strength, its simplicity, is also its greatest weakness, because it allows an attacker to perform what's known as lateral movement. And this is where things get really, really scary. If an attacker compromises just one of your public-facing web server pods, they now have a direct network connection to your most sensitive assets. They can start scanning for databases, hitting your internal APIs, and just spreading like wildfire across your entire infrastructure. The potential blast radius is just enormous. So, how do we fix this mess? Well, it's time to start building some of those internal walls. In the world of Kubernetes, these walls are called network policies, and they let us completely flip our security model from maximum trust to something much better, zero trust. Zero trust sounds intense, but the idea is actually super simple and incredibly powerful. Trust nothing, verify everything. When we apply this to our cluster, it means we assume that no communication is allowed, unless we create a specific, explicit rule that permits it. We're going to start by denying everything first. And get this, with one tiny little piece of YAML, we can completely lock down an entire namespace. This policy right here, it selects all the pods, and it applies rules for both incoming traffic, that's ingress, and outgoing traffic, egress. But you'll notice there are no actual rules listed. And you know what that means? Nothing gets in and nothing gets out. It is total, complete isolation. And that's our brand new secure starting point. Okay, so we've slammed all the doors shut, everything is locked down, awesome, right? Well, not exactly, because now our applications are completely and totally broken. They can't talk to each other, they can't talk to anything, and that's exactly what we want. Now we can start the real work, methodically opening only the very specific pathways our application actually needs to function. So you go ahead and you apply that default deny policy, and instantly everything breaks. But why? What's the very first thing that fails? Well, there's one critical dependency that pretty much every application has, and it's the first victim of our new firewall. It's DNS, of course. Your backend service can't find your database because it can't resolve the name myDatabaseService into an actual IP address. That DNS query just gets dropped into a black hole, the application waits, and eventually you get a really confusing unknown host error. The fix is to create another policy, one that specifically allows outgoing or egress traffic on port 53. But, and this is so important, we only allow it to go to the core DNS pods that live in the kubesystem namespace. A really common mistake is to just allow port 53 to go anywhere. Don't do that. That can be a backdoor for attackers to sneak data out of your cluster. This rule is precise and it's secure. Okay, let's walk through a classic example, protecting a database. First, we put a policy on our database pods. This policy has one very simple rule for incoming traffic. It allows connections on the database port, let's say 3306, but only if that connection comes from a pod that has the label role backend. That's it. Now, even if our front-end web server gets compromised, the attacker has no network path to get to the database. It's completely isolated. Now, this is a little detail that trips people up all the time. It's about how the YAML is structured. See, if your rules are separate list items, it acts like an OR statement. Traffic gets through if it matches the first rule or the second rule. But if you put them in the same list item, it becomes an AND. Now, traffic is only allowed if it matches both conditions. Getting this wrong is probably one of the most common ways people accidentally create a security hole. So we've written all these great policy rules, but who's actually, enforcing them? Well, it's not Kubernetes itself. That job belongs to a totally separate component called the CNI, or the Container Network Interface. The way to think about it is your policy is the blueprint, but the CNI is the construction crew that actually shows up and builds the walls. And listen, this is a massive gotcha. I mean, it is absolutely critical. If the CNI you're using in your cluster doesn't support network policies, then you can write all the policies you want. Kubernetes will accept them without any errors, but nothing will actually be enforced. Your network will stay wide open, and you'll be left with a completely false and very dangerous sense of security. This just goes to show how much your choice of CNI really matters. For a long time, the default CNI on AWS didn't even support policies. Now it does, which is great. But other CNIs like Calico or Cilium, they offer even more advanced features, like policies that can apply to the whole cluster, not just one namespace. And, maybe most importantly, they give you much better tools to actually see what's being blocked. So there you have it. We've gone from that wide open city to a much more secure, properly segmented environment. Let's just wrap this all up with the key takeaways that you can use to go and secure your cluster like today. Here is your 3-step action plan. It's super simple. Number 1, in every single namespace, start with a default deny policy as your baseline. Number 2, immediately follow that up with a very specific targeted rule to allow DNS traffic. And number 3, before you do anything else, go and confirm that your CNI plugin actually supports and enforces these policies. Now, I have to give you one last word of warning here. The hardest part of all of this isn't writing the policies themselves. It's debugging them when they don't work. Because when a policy denies traffic, the network packet just vanishes. It's silently dropped. Your application just times out, and you get absolutely no error message telling you that a firewall was the problem. And that really leaves us with a final important question. Your network is locked down now, which is a huge security win. But true security isn't just about building walls. It's about being able to see what's happening behind those walls. Can you actually observe the traffic? Do you know what your policies are blocking and why? That's the next step on the journey to a truly secure cluster.